So let us start the next topic. So we have already discussed about the proofs of Wien's radiation law and Rayleigh-Jeans radiation law. So let us move ahead to the next topic, which is Compton effect. Okay, Compton effect. So what is this and what does it represent? So Compton effect is the effect of wavelength on a particle. Okay, so we will better understand this by the formula itself given by the Compton. So the formula holds del lambda equal to h by m naught c 1 minus cos phi. Okay, so you might be wondering what is del lambda, what is h m naught c 1 minus cos phi, what is cos of phi, what is phi there. So before getting you understand about these things, you are already known to that which is h is nothing but the Planck's constant and c is the speed of light in vacuum. These two are although these two are the constant terms, m naught is the mass of a particle of which Compton effect is observable. So what is m naught? M naught can be the mass of electron. What is the mass of electron? Mass of electron is nothing but 9.1 into 10 to the power minus 31 kg. Okay, and h holds the value of 6.626 into 10 to the power minus 34, and c is 3 into 10 to the power 8 meter per second, speed of light in vacuum. Phi is the angle of scattering. Okay, cos of that component is taken as cos of phi. What is del lambda? Del lambda is actually the Compton shift. Okay, so del lambda is actually written as lambda minus lambda prime minus lambda. What is lambda and what is lambda prime? Lambda prime is the wavelength of unmodified particles, and lambda is the wavelength of modified particle and wavelength of unmodified particles. Okay, so difference of these two is known as Compton shift, and which is already equal to this one. So what we can write, if we consider this to be equation 1, this to be equation 2, we can write from 1 and 2 if the left hand side is equal in both the equations, so that the right hand side of these two equations should be equal. So by that principle we can write lambda prime minus lambda to be equal to h by m naught c 1 minus what? Cos of phi. So that is the relation, means that is the equivalent relation for that Compton effect. So we will understand this topic in a good manner by solving some numericals on it. So what may be the numericals on this topic? You might be told to calculate the value of Compton shift on a electron by certain angles. Let's say the angle would be 30 degree, 60 degree, 90 degree, 120 degree, whatever told in the question, you have to derive the Compton shift in that question. So there may be two cases. Okay, to get the, let's say this is the equivalent equation of Compton effect. So let us think here, del lambda equal h by m naught c into 1 minus cos phi. Let us think in this equation, for what value of phi, means for what value of angle of scattering, the del lambda, which is Compton shift, will be maximum. Means for what value of phi this thing to be maximum one. What may be the value of phi? So for case 1, just write the case 1. For maximum del lambda, which is Compton shift, for maximum Compton shift, phi equal what? Actually, try to understand what may be the value of phi so that this term will get maximum. So you might think that means phi, if we substitute phi to be 0 degree, we will get the maximum value of del lambda, but you are wrong at that stage, because it is not only cos phi will be maximum at that point, but it is something which is 1 minus cos phi. To make it maximum, we have to make this term to be the maximum one. So if the phi is nothing but 180 degree or pi radian, we know that in the radian system it is pi radian, in the degree coordinate it is 180 degree. So cos of phi, what will be cos phi? Cos phi will be cos of pi or cos of 180. So it will be minus 1. We know well in the radian system it will be minus 1. So in that context, if we go with 1 minus cos phi, so it will be 1 minus of minus 1, which is actually 2. Okay, so 1 minus of minus 1, 1 plus 1 is equal to 2. So del lambda will be, at maximum case, it will be twice of h by m naught c. Okay, and we know that h by m naught c is also a constant thing which can be written as lambda c. Okay, we are just assuming this to be the lambda c. So we can write what? We can write del lambda at maximum twice of what? Lambda c. So that is the case for maximum del lambda, means maximum quantum shift will be observable when the angle of scattering is what? 180 degree. Okay, so let us move ahead to the case 2 of this context. Case 2, just guess what may be the case 2. If the case 1 was about the maximum Compton shift, obviously the case 2 will be about the minimum Compton shift. So when the Compton shift will be minimum, try to think. So there we have to find for minimum del lambda what may be the value of phi. At what value of phi this del lambda will be minimum? Just try to answer this. Okay, just assume if we put phi to be 0, it will be 1 minus 0, del lambda equal to lambda c. If we put phi equal to 180 degree, 1 minus of minus 1, which is 2, twice of this thing. So when will it be 0? Acha, when we put, if phi equal to what? Pi by 2, it will be cos pi by 2 will be 0. So it will be equal to what? Del lambda equal to lambda c. But it's not the minimum case. There is something which is, and we know the lambda c to be h by m naught c. This is not actually less than that. So this is not the minimum condition, but this is the condition when Compton wavelength is equal to the actual wavelength of that. Okay, so we will come to how actually this is coming. Lambda c is how h by m naught c. I will explain this later. So till that, just be with the video. I will explain this, how is it coming in this structure, means h by something mass into some, what is c? C is something velocity or something. Okay, how is it coming like this? I will be explaining it later. Now till then, just be with me. And for minimum del lambda, what may be the value of phi? Okay, to make it minimum, we know that sine and cos, let's say sine theta is from what? Minus 1 to plus 1. Range of sine theta as well as cos theta is what? Minus 1 to plus 1. Means the value of these two can be minimum minus 1 and maximum plus 1. So if we put the plus 1 part, so 1 minus plus 1 means 1 minus 1, it will be 0. So for minimum del lambda, it will be del lambda suffix minimum equal to what? H by m naught c 1 minus cos of phi, means cos here should be 1, means at cos of what? Cos of 0 degree. So del lambda minimum will be equal to h by m naught c 1 minus 1. So del lambda, which is minimum, will be equal to 0. 1 minus 1 is 0. 0 multiplied by something is already 0, means it is obviously 0. So for minimum del lambda, phi should be, we got our answer, phi should be 0 degree. Okay, that is the case, and we are getting del lambda minimum to be equal to 0 when phi equal to 0, and when phi equal to, earlier we have derived that when phi equal to 180 degree, del lambda equal to twice of lambda c. When this is one number, when phi equal to what? Pi by 2 or 90 degree, del lambda equal to 9 lambda c, and when phi equal to 0 degree, del lambda becomes 0. These are the three conditions which is often asked in the examination to derive, or in just MCQ for 1 to 1 marks. Okay, these are the means very required kind of questions. So for the better understanding of this topic, the questions related to this topic is very vital and very important from the exam point of view. This question carries 2 marks and it is already asked in the Macau semester exams. Okay, this is the question is about, will there be any observable Compton shift in visible light? So visible light that we can visualize, that is the visible light that we already familiar with in our day-to-day life. So what is visible light? I mean by the visible light, what is the wavelength range for this visible light? So we know, to start the solution of this question, we have to write the range of visible light is from 4,000 to 5,000 Armstrong. We know the Armstrong thing. Okay, 4,000 to 5,000 Armstrong. So what is the formula for Compton shift? We have just learned about the Compton shift. So the formula for Compton shift is h by m naught c 1 minus cos phi. Okay, that was the formula. So what about this wavelength? So we have to think about this one. If it is like this, so will there be any Compton shift? Means in this context, will there be any Compton shift associated with visible light? Means we have the value of lambda here to be, means if we consider the lower one, means the 4,000 one, lambda equal to 4,000 Armstrong, we have to calculate the del lambda. So let us find this by using this relation. How we can do? Just tell me how we can do this. Is there any method means which can do this calculation for us? So I think you have done this question in the given specified time limit. If not, then go with the solution. How to solve this question? This question is about, will there be any observable Compton shift? So we have to check whether there is some Compton shift or not for the given range of wavelengths. So let us consider the lesser wavelength, so that would be easier for us. So let us consider lambda to be 4,000 Armstrong of the visible light. So in the maximum case, means at del lambda maximum, what we have got from there, it was equal to 2 of lambda c, where phi was equal to what? 180 degree, means the angle of scattering was 180 degree. So we got this value earlier. So 2 of lambda c. So how to evaluate the lambda c? Lambda c is nothing but h by m naught c, as I have told before. So how to do this? So just putting the value of h, m naught and c. What was m naught? M naught was mass of electron. So mass of electron is how much? We are known to these things already. So 3 into 10 to the power 8. So this thing we can have by our calculator. So putting this result here, we will have 2 into, just calculating these things, we will have 2.427 into 10 to the power how much? Minus 12. So this will be equal to, just multiplying it by 2, we will have 4.85 into 10 to the power minus 12 meter. So we want this to be in Armstrong. In Armstrong, what we can do, we know actually in 1 Armstrong it is equal to 10 to the power minus 10 meter. So can it be written like this? Yes, obviously. So just taking these two together, we will have divided by, we will have this thing to be 0.0485 into 10 to the power minus 10 meter, which is nothing but 1 Armstrong. So it is in Armstrong format. We got the value to be this, and we have the lambda value to be 4000 Armstrong. This is given in the question and we have derived this. So let us move ahead in this question. What we can do further? So after reaching the value of del lambda at maximum point, so it will be equal to check the observable, where it is observable or not. What we can do, we can find del lambda by lambda. It represents the percentage change in lambda. Okay, del lambda by lambda. What was del lambda? Del lambda maximum, we got 0.0485 divided by, what was lambda? It is given in the question 4000. Okay, so it will be equal to what? Just let us divide these things together. 485 divided by 4000, we will get 1.21 into 10 to the power minus 5. So this is not in the percentage. To calculate its percentage, multiply this with 100 into 100. Now it will be in the term of percentage. So just doing it, 1.21 into 10 to the power, this is 100, this is minus 5, it will left with minus 2. So it will be 0.0121 percentage. So just think, in general, we are getting the percentage of visible light that will show Compton shift is equal to 0.012%. Means this amount of percentage is very less to show Compton shift. Therefore, in the last concept, to conclude this question, we will write, since del lambda by lambda, which is percentage change in Compton shift in wavelength, is very low as 0.0121 percentage. Therefore, it is impossible to observe Compton shift in visible light. It is impossible to observe Compton shift in visible light, as visible light wavelength range from 4000 to 5000 Armstrong. So you might be wondering, why do we consider this 4000 Armstrong? Why not the 5000, or why not the in middle of these two? So why do we consider this 4000 only? The simple reason behind that, to find the maximum Compton shift, we have considered the maximum thing. We want this to be observable, but the conditions, means the wavelength, the lower the wavelength will make the higher chance of getting some Compton shift, but we get the lower part, means we get the lowest value of lambda, means wavelength, that actually was not sufficient to make this percentage go far. So that as the percentage is very low, we cannot observe any Compton wavelength in this wavelength range. Okay, although there are other rays where Compton shift is observable except this visible light. So this question was just to build the base of the Compton shift. Okay, so we will be doing means a number of questions together in the questions video, where we will discuss only the questions and numericals related to every topic we discuss in the videos. So now let us move ahead to the wave particle duality part. Okay, wave particle duality. Wave particle duality. Wave particle duality part, where we will study the dual behavior of a particle as well as wave in context of de Broglie wavelength, which is kindly denoted by lambda suffix d. De Broglie wavelength. I have mentioned in this video, I know that I have mentioned in this video that Compton wavelength is equal to what? Compton wavelength was equal to h by m naught c at phi equal to pi by 2. Okay, that was the condition, h by m naught c in general case. So I have discussed there why do we find the lambda c to be this, why is this in this format. So we will discuss why h by m naught c is something that denotes the lambda c. Actually in Compton shift also there was something called dual particle, means dual nature of particle and wave. That's something the particle shows both nature, means as a particle itself, and a wave nature also is shown by the particle. So that is the case in which lambda d is equal to h by p. What is p? P is the linear momentum of the wave nature shown by the particle. H is the Planck's constant, we are known to that term also. So in the next step there will be multiple formula to calculate the de Broglie wavelength. Okay, h by what? mv. Okay, linear momentum is, since linear momentum, p is what? Linear momentum, okay, is equal to mass into velocity. Okay, mass into velocity. So lambda d equal to h by mv. So this is the formula number 1. This will be formula number 2. The formula number 3 for calculating the same lambda d will be equal to what? H by root under 2 mass mk, where k is the kinetic energy of the particle. Kinetic energy of the particle. And I am sure that you guys know about the rest terms, which is h, m and v, as I have discussed. M is the mass of particle, v is the velocity with which the particle is moving. Okay, that is k. How is it coming? I will derive this relation also, means how this relation is coming to be like this. Okay, actually this is linear momentum, p is linear momentum. There is something called angular momentum also. So let us know it for the knowledge purpose, which is denoted by L equal nh by 2 pi. It is the part of Bohr's atomic model, and we have studied this in our later, means class 12 sort of things. So L equal to nh by 2 pi. H by 2 pi is nothing but h cross, denoted by h cross, nh cross. L is the angular momentum. So we don't need these things in the calculation, but these three formulas are very vital for the questions and their solution. So these three formulas are must known to everyone to solve any single numerical based on this topic. Actually, there was something I called before, which is lambda c, which is equal to h by m naught c, where just give some attention between these two terms, m naught and c. What is m naught? M naught is the mass of the electron, and c is wavelength of not the wavelength, c is the speed of light in vacuum. So this is something kind of mass, and this is something velocity. Okay, and this formula number 2 holds what? Lambda d to be equal to h by mv, means this is also mass and this is velocity. Now you will be able to know that lambda c is nothing but there is something similar to lambda d. For that, de Broglie wavelength is introduced to study the further behavior of the particle when it is find that it shows the both nature, wave and particle nature. Okay, so the numericals that we have discussed, means the question that we have discussed till now, is just for the reference purpose. To understand better this topic and to excel in the examination with the best question selected by me, you have to attend that question answer session, in which we will be doing only questions and answers to solve those questions. And you are known to the fact that in today's time, means in now, means Macaut introduced the question paper to be the fully the numerical one. Means there is some theoretical question also, but very less amount of question is for the theoretical part, and more of the questions is based on the numerical part. So you have to excel that numerical part very clearly and very quite confidently. To excel that, you have to attend that session, and this question was just for building the base of the Compton shift that we have discussed, and the wave particle duality. We have to do a lot of question based on this. So keep studying.